Hello students. So today I just want to go through very quickly on this chapter called percentage for secondary one. Um, Now this is a video made because we want to cover the syllabus as quickly as possible. That was the plan. However, it will be not very useful if all you did was to just watch the video from beginning to end. It doesn't really help you to learn. So my recommendation is as I go down through these notes, as I go through these notes, I will actually hit all those work examples and I will actually provide the solution. However, because you're watching this as a video, I strongly recommend that at each activity, you pause the video, you try it out first, attempt the questions, then when you're done, you continue playing the video and to compare your answers and to reflect on any mistakes that you made. That will be more efficient in your learning. All right. So please do take note. I do really want you to learn this chapter properly. So let's begin. Now, the first portion here on enduring understanding and essential question, of course, do spend some time to read them on your own. You have the hard copy notes. You can do that. So we will just move down. Here's a study companion made by another teacher. Very useful. Okay, so inside this link, it will actually bring you to a Padlet where many examples are worked out for you, and there may be even some videos for you to actually watch and follow along. Okay, micro videos, right? So let's continue. Okay, learn PF. Do complete it as per instruction. I'll give you instruction in class to do this. So here's the first thing we need to know, right? So since we are dealing with percentage, basically percentage is another way to display a number, right? However, okay, it is usually displayed. Sometimes we have the percentage symbol, and quite often we mistake the percentage symbol as a form of unit. I mean, it functions like unit, but the idea really is because when we certain values is in decimals, right? And we want to too small. We want it to actually make it larger, right? For example, if I say 10% discount, people see the number 10, it makes a lot of sense to them. We can process the information. But if I tell you that the prices are going at 0.9 value, it's actually the same piece of information, but it confuses people. So the ability to actually switch uh, the different form of displaying numbers and values in terms of percentage, fractions, and decimal is a very important skill, right? So we're going to do just that. So let's begin by moving from percentage to fractions and decimal. Now, the word percent, cent means 100. So percent means per 100. So basically the percentage symbol simply means upon 100, if you will, right? So in this case, all I need to do, let me change the color of my pen, is that this is 18% will simply be 18 over 100. And of course, as a fraction, we will want to display in the simplest form. That will give me 9 over 50, right? Now, in terms of decimal, right, all we need to do is actually to divide by 100. That means to shift the decimal point to the left. So this will give us 0.18, and of course, we put 0 in front here as a placeholder, so that it makes a lot more sense. Okay, so now you get a basic idea. We can complete the rest of the table quite quickly. As I advise, you should pause the video, try them out, unpause, and compare your answers with mine, right? So I'm just going to do this, 0.25%. This will work out to be 25 over 10,000, which works out to be 1 over 400, right? On this side, we'll shift the decimal places, so it'll be 0.0025. Okay. Now 1 and 1/3. 1 and 1/3 is same idea. Okay, we have 1 and 1/3 over 100. Okay, if you use your calculator, this will give you 1 over 75, right? And on this side, on the decimal side, we do need to actually work it out. Okay, so it will actually give us 0.01333 recurring. And when we write it as 3 significant figure, it will be 0.0133, right? So I will label this 3 significant figure. So there's no confusion over there. Okay, the next set of numbers is where we go from fractions to percentages, right? So one of the most direct way to do this is to multiply by 100%. Well, mathematically, 100% simply means the value 1. So we are multiplying by 1. We are not changing the value, just the way that we display the number. right? So we have 3 over 125 multiplied by 100%, right? So this will give us 12 over 5%, and we can display this as 2 and 2/5%, right? So this is fine. Now to go to decimal, we just make use of our calculator, right? So this will be 0.024. Okay, so 21 over 20 times 100%. This will give us 105%, right? As a decimal, it will just be 1.05. Okay, now 1 and 1 over 14. Okay, I'm going to do, 14 over 15. 1 and 14 over 15. Do the same thing, right? And this will work out to be 580 over 3%, which is equivalent to 193 and 1/3%, right? So in terms of decimal, it will be 1.933 recurring. Writing as 3 significant figure, it will be 1.93, 3 significant figure. Okay. Now, the final two values, we have decimal and trying to convert them to percentage. So the idea will be the same, right? Because I'm going to multiply by 100%, right? So 0.0034 times 100%. Okay, so I'll take the value times 100 and leave the percentage symbol there, which will give us 0.34%, right? In terms of fraction, what I'm going to do is I'm going to write down 34 over 10000. That will match the number of decimal places, the number of zeros here. And simplest form, it will be 17 over 5,000, right? Okay, one more set of numbers, 16.8. So 16.8 times 100%. This will give us 1680%, right? So in terms of decimal, it will be 16. Now the 0.8 is actually 8 over 10. Okay, so this is the situation. Now writing in simplest form, this will give us 16 and 4 over 5. Okay, so I hope that works for you. Let's move on to the next section. The next section wants us to express one quantity as a percentage of another. That's another big idea behind fractions and percentages. We can actually do that, right? So here we have some examples to practice. Okay, again, you can pause your video, try them out, then after that resume, right? Okay. So what I'm going to do is some things we need to take note first, right? Because the units is different. So I need to actually make the unit equivalent first, right? So the strategy here is to make them the same units, right? Oops, singular here, unit, right? So I can either convert the seconds to minutes or minutes to seconds. It works either way, right? So what we can do is we can look at this and say, okay, 3.5 minute is actually the same as, so I multiply by 60, which will give us 310 seconds, right? So that means now we have 25 over 310 times 100%, which gives us 11 and 19 over 21%, right? Now, same here, over here, the year, I know that 1 year is actually 12 months. Okay, so this will give us 12 over 4 times 100%, which gives us 300%, right? Okay, one more example. Express 335 centimeter as a percentage, right, of 5 meters. So the first thing we need to do is, well, there's somebody actually did this, and there's actually some issue with this, right? So can you tell what's wrong? Yes, okay. So if you got it, then great. Okay, so because the units are not the same, right? So this is Great Ben, incorrect, right? So instead, what we should do is to make the units the same, right? So 5 meters will give us 500 centimeter. That means now we have 335 centimeter over 500 centimeter, right? Times 100%. That should give us 67%. There we go. Okay, next one. Find the value of each of the following. So now we straight up just find a percentage of a value, right? So we can do that. So 0.8% of 4.5, we actually multiply by 4.5 to get that, right, meters. So what we have is 0.8 over 100 times 4.5 meters, right? And this works out to be 9 and 2 50 meters. Now, because the percentage is in decimal, so sometimes this type of question, we want to match the question with the format of our answers. We do match the question. So in this case, since the question is decimal, if I were to write this as decimal, it is 0.036 meters. Okay. Now on this side, of course, 111 and 4/5 is in decimal. So we can leave this as a fraction. So let's do this. So 111 4/5 percent times 24 kg, right? This will be 111 4/5 over 100 times 24 kg. Okay, we work this out to be 20. That's right. That's improper fraction first. 3354 over 125 kg, right? And this will be the same as 26 and 104 over 125 kilogram. Okay, so that we have. So let's move on to the next section once you're ready. Okay, in the next section, we want to compare two quantities by percentage, right? So here's the example. Joseph shows Paul his mathematics results, right? Then, Joseph, or is it 1号? But anyway, explain why Paul thought Joseph obtained the best result in test 2. Right, so if you look at this, maximum marks is different, right? Then we have the actual marks on the right. So yeah, this is not 1号, or this is not Joseph, right? This should be, let's change 1号to Joseph. Let's not confuse, right? So explain why Paul thought that Joseph obtained the best in test 2. Well, because, test 2, right? In test 2, the raw score, right, is the highest, right? Because oops, I'm spelling because wrongly. This is terrible. Because 35 is greater than 25 is greater than 18. So this is what Paul did, because Paul didn't really quite understand about percentages, right? So part 2, do you agree with Paul? No, right? So instead, what we should do is we should calculate the percentage, right? So test 1, what's actually happening is we have 18 over 25, and this is actually 72%, right? Test 2 is you have 35 over 50. So if you work this out, this is 70%. And test 3 is 25 over 40, which is 62.5%. So actually, Joseph did the best at test 1, right? So because this is the highest result, okay? So we actually compare using percentage is better because the maximum marks is different, right? Okay. So here's another activity, right? The graph on the right shows the percentage of students who travel to school by bus across 4 different schools. So this is fine. We have A, B, C, D, right? So do you agree the following statement? The statement says what? The bar graph shows that a bigger percentage of student A travel to school by bus, okay, compared to school C. Yeah, right? So you look at this, it's already in percentage, right? So it is already displayed in percentage form. So yes, all right? Okay. Agree, okay? The bar, let's confirm it now. The bar graph shows that a bigger percentage of school A. Yeah, so the graph is already written in percentage form, right, compared to school C. So yes, 80% percent is greater than 30%, right? Okay. So the bar graph shows that there are fewer students from school D travel to school. Now this one, okay, not necessary, right? How do you spell necessary? Necessary. Okay. Why? Because the percentages alone does not give us the raw number, right? We can't tell, so we need to compare with the raw number. Okay, so now let's look at the next one, considering only school B and school C. Okay, school B and school C, let's take a look. Okay, I have the values there. In total 55% of the students travel to school by bus. Can we do that? Of course no, right? Cannot. No. Okay, we cannot add the percentages as the total number of students is not the same. All right. Okay, so these are some things that we should be aware of, right? So yeah, so the key idea here, right? Let me highlight that for you. Okay, when making comparison, we got to be mindful of the base, okay, because they are different total value. Okay, practice time. So here's a very interesting question. Okay, so at the hawker center, there are 3 drink stalls, right? Store A, so etc., etc. Okay, so you can read the question first. You can pause and read the question, right? And we're going to try to use Poya's 4-step to really unpack this question, because this question is will be useful, right? Because there are lots of data over there. When you are given a lot of data, it'll be useful actually to organize the data in the table form. Okay, so I've already organized the table in the table form. There are 3 stores here, and then there are 3 pieces of information we are dealing with, right? We have the number of glasses prepared, we have number of glasses sold, and then we have the percentage sold. So let's fill in the value that we know. So you will follow along with your notes. Okay, sugar cane, down here we have 200, right? So we have here we have 220. Over here we have 175. Over here 180. Okay, we have 85% here, and we have 80% here. So our task right now is to fill in the rest so that we can do a proper comparison. Let me change the color of my pen so it's visually more prominent. Okay, so store C, okay, what we have is that it's 80%, right? 80% of so we got 80%. Now 80% of a unknown, right, is 80% of the, we know the amount that is sold is 180, but we do not know the base. Okay, so 80% of X is 180, right? So this means 80% means 80 over 100 with 0.8. That means 0.8x, okay, which is the unknown we are trying to find, is 180. That means the actual value here, right, the number of glasses prepared for herbal tea is actually 180 divided by 0.8. That will give us 225. Okay, so some calculation needs to be made. Now in the second one, soya bean, number of glasses sold, we know that's 85%. So it's 85% of the total, right? So the total is 220. So if we work this one out, this will be 85 over 100. Let me write better handwriting. 85 over 100 times 220, which will give us 187. Okay. Now finally on the left column, okay, we have the number of glasses sold and number of glasses prepared. We want the percentage, so now we just take 175 over 200 times 100%, which will give us 87.5%. So now we have all the data, right? Once we have all the data, we can go ahead and answer the question quite readily, right? So first question, which store sold the greatest number of glass? In this case, it will be store B, right? It's 187. Okay, let's take a look. Confirm it. 187 is greater than 180, greater than 175. which store sold the highest percentage, right? So we look at, now we compare the percentages. Well, store A wins, right? So store A, okay, because the highest now is 87.5%, right? 87.5%. Okay, which store prepared the greatest number of glass? So, well, again, do a quick comparison. We know that it is going to be store C. Okay, it actually prepared 225 glasses, right? Okay, so this is how we can actually tackle this type of question. I hope it's useful for you. Okay, let's move on. Okay, so the highest percentage is different from again whether the question they ask, right? The store with the highest percentage will earn the most profit. It really depends on how much you charge for the drink and the cost price. So there are lots of other factors. So all the data tells us is actually the percentage of the, or rather the proportion of the drinks sold and how much cups are there. It doesn't really tell us more information than that. We need more information to actually answer this type of question. All right. Okay, let's move on to the next section quickly, right? So next section, we have a few things to talk about. We want to talk about percentage change, reverse percentages, and percentage point. Okay, again, there's a Learn PF activity that you try out, so please try it out. So once you are done, you can pause the video, try that out, and then come back here, right? So now let's come back. Percentage change and reverse percentage. So reverse percentage, what does it do? Okay, what it means is that now we want to talk about increase and decrease. Okay, and then we have new value compared with the original value, or the original value getting the new value, right? So we know how to reverse the process. Okay, so let's look at some proper question. So we have practice 3, right? So in practice 3, it asks us to increase 28 by 125.7. Now, here you need to take note, right? Increase by 125. So is it 125.7% times 28? It is not, because 125.7% is the increase. It's not the final result. So there are two ways to do this. We can either find 125.7% times 28, gives us 35.196. Therefore, the new value, right, is going to be 28 plus 35.196. Let me write neater. Yeah. Which will give us 63.196. However, let me change the color of my pen again. Another way to approach this question is to realize that, okay, the new value I originally at 100%. If I increase by 125.7%, the new value is actually 225.7%, right? So I can directly say that the new value is going to be 225.7% times 28. Okay, and we get 63.196. Okay, so there are two ways to actually do this. Choose the method you like and stick to it, right? So I will just go with I'll go with the blue one, right? But if you do the purple one, there are 2 steps to it, right? So next, decrease 216 by 37.5%. So what we do here, right? We need to start from 100%, right? Start from 100%. So my new value is going to be 100% minus 37.5%, right? Okay. Yeah, this is in percent. This is in percent. Okay, over 100%. Okay, times 216. Okay, we do that, right? So actually down here, you should put the percent here. Okay, but it's fine. Okay, so find the difference. Okay, that's the decrease over the original, which is 100%. So we work this one out. This will give us 135, right? Okay. Now question 2, find the value. This time round, the result of a number, you're going to call it x, when increased by 15 is 161. So now we have the end result. We want to actually sort of work backwards, right? So if it's increased by 115%, means 115%, okay, represents, okay, 115% is actually 161, right? So the dash, actually I don't quite like the dash, right? Because dash can mean many different things. Okay, so what a better way of presenting this, because we just write the word represent. Okay, Represent is better. So 115% represent the number 161. So if you are interested, we can find 1% first and then find the 100%, which is the original number, right? And another way, okay, a quicker way is if you know what you're doing, 100% represent is to just take the 100% over the 115% times 161, right? Which will give us the number 140, right? So the number is 140. Okay, so you can write number equals 140. So down here, same idea, right? So the value of after the increase is 192. Okay. So the 20% is the decrease. I start from 100, right? So 100 decreased by 20 is 80%. So 80% represents 192. So I want to find 100 represents 100% over 80% times 192, which gives us the value of 240. So the number is 240. Got that? Okay. So here's the next activity. It's quite interesting, right? So the next activity is this. Because of the way it is calculated, right? If I have a value I increase by 10%, then I decrease by 10%, I don't actually get the same value back. And this little exercise actually helps you to do that. So I want you to pause the video, try it out yourself, then unpause to actually figure it out, but to compare, right? So I'm just going to write down very quickly instead of walking through this because it can be very tedious. I know you can try it out yourself, right? So spend some time, try it out yourself. Okay, so I'll just fill in the numbers. You can pause the video and compare your answer later on. Right, so very quickly, this is 66 and 2/3. Okay, this one is an increase, and this is 50%. So you can see actually the values are quite different, depending on which direction we go. Right, so this is an increase. This is 150. This is decrease. This is 40. My handwriting. Oops. No, Siri, go away. 40. This is decrease. And this is 33 and 1/3. Okay. So now you can continue. Next example, practice 4. Okay, same thing. Pause the video, try it out first. Then after that, we compare. Okay, so this practice, the question goes like this. The total births in Singapore fell, okay, from this value, 41250, after a year of recording high birth of 42185, right, in 2016. So the expert attribute to the SG50 effect, well, maybe, right? Okay, so it continued to fall by 4% again in 2017. So calculate the total births in 2017. So now what happened is we can visualize, right? We know that we start from in 2015, okay, we start from 42185. Then it drops to 2016, it drops to 41251. Then it drops again to 2017, a value that we do not know. So this is a situation. But we do know that this drop here is actually a drop by 4%, right? Decrease, 4% decrease. So this is the information that we have, right? Okay, so let's work this one out. Okay, so the total births in 2017, okay, I mean it dropped by 4%, which means the total births is actually 96% of the previous year. So 96% times 41251 is actually 39000.96. Since this is the population, we usually don't have decimal for population, right? So we round this off to the nearest integer. Okay, it should be 39601, right? Nearest integer. There we go. Okay, right. Part 2, calculate the percentage decrease from 2015 to 2016. So the decrease, right, is actually the difference between this value here and this value here. So we're going to do that. So the percentage decrease is actually the difference, which is 42185 minus 41251 over, now what we want to write, the denominator here is the original amount. So in this case, the original is 2015, right? 2015 is 42185. Okay, times 100%, which will give us 2.21405%, which is 2.21% in 3SF. Okay, let's move on. Practice 5. Okay, practice 5, here we have a length of rectangle twice that of breadth. So if the breadth is x, then the length will be 2x, right? So we have that. Okay, so the original, we want to find the original parameter. The original parameter is 2 times x plus 2x, right? Which works out to be 6x. Okay, now what happened is, after increased by now the question is, if the length of the rectangle is increased by 20%, while the breadth is decreased by 20%, let's see if there's any change in the parameter. Okay, so let's try it out. Okay, so after increase by 20%, the new length is 120%, right? Times the length is 2x, right? So this is actually 2.4x. So this is 2.4x. Okay, then after decreasing by 8%, 20% here, so this is actually 80% times x. So this will be 0.8x, right? So 0.8x. Okay, so now the new rectangle, okay, the perimeter will be 2 times 2.4x plus 0.8x, which will give us 6.4x. Here is different, right? Okay, originally the perimeter is 6x, now it's 6.4x, so it is different. So we need to take note. So interesting result. Okay, so to summarize, okay, percentage change, perimeter of the new rectangle minus perimeter of the original rectangle, and the denominator is always the original, right? Original. Okay, so in this case, the difference, the percentage change now will be 6.4x minus 6x over the original 6x times 100%. Okay, so if we work this one out, this will be 6 2/3%, right? So in conclusion, there is that change? There is percentage change in the parameter. Alright, so I'll pause the first video here. The second half of the notes will go into the next